Hello everyone, Mr. Fawcett here, and today we're going to continue our discussion on the relationships between original functions and their derivatives. And we're also going to get into some more specifics on the tangent line aspect of a derivative and some of the things that we can use a tangent line for. So today's mostly just practice problems. There's a few little new ideas that are going to pop up based on our work that we're doing, but nothing specifically new as far as original concepts go. So probably maybe 2 to 3 parts. We'll see how long these questions take. But as always, I encourage you to attempt the questions on your own and then come back and just use this video to fill in whatever gaps you still had after working through. Okay, let's get started. We have a graph here. It is the graph of f of x, which is equal to 1/2 the squared quantity x plus 2 minus 4. So today it's going to be really important to make sure you understand what functions we're being given. So are we being given the original function or are we being given the derivative? Because if you confuse that, then it's going to make your answers to the rest of the questions most likely incorrect. So if question number 1 says estimate f prime of -4 and explain what this value represents in terms of the graph of f of x. So again, we're estimating. They're not asking us to go through and actually find the derivative here algebraically, even though we could. All we're going to do is sketch a tangent line at x equals -4. Okay, so not the perfect tangent line. Let's try to be a little bit better. Something like that. And a derivative is the slope. So we're essentially estimating the slope of that tangent line. Now, again, your slope should at the very least be negative. It shouldn't be, this is not a horizontal tangent line. This is not a tangent line with a positive slope. If you went through and used this function to find the derivative algebraically, you would come up with a slope of -2. So that's what I'm going to go with. You may come up with something slightly larger, slightly less than -2, but I am just going to work with what it would be if we found the exact derivative. So f prime of -4, in your case, you're going to have approximately equal to. Because I know that the actual derivative is -2, I can put equal signs. So again, a derivative is the slope of the tangent line. So this means that the tangent line to f of x at x equals -4. I'm not going to put my comma there. It's not how English works. There we go. Has a slope of -2. All right. Number 2 says, find the equation of the tangent line drawn to the graph of f of x at x equals -4. Sketch the line in the graph above. So we need to figure out a few things. When we are trying to find the equation of a tangent line, we're going to start off with point slope form. So y minus y1 is equal to m times the quantity x minus x1. We know what our m is. We've already found that from number 1. So we know that our m is -2, so we can fill that in. And we know that our x is -4. So then we'll have x plus 4 inside parentheses. Now we just need to find our y1. And you may think, okay, how do I do that? Well, they give us the graph of f of x. So we could look at x equals -4 and look at what our y value is. Or we could use our equation, right? We could substitute in -4 into our function and get a y value. In this case, it ends up being -2, so y plus 2, and this would be the equation of our tangent line. Remember, you don't have to convert this to slope-intercept form. What I boxed is a perfectly acceptable answer on the AP Calc exam, and if you try to convert it to slope-intercept form and you make an algebraic error, they're going to take some points away, even though you originally had the answer correct. So the last part of this problem just says sketch the line on the graph above. Well, we've already done that, right? We actually did that to estimate the slope. So we've already drawn the tangent line. Okay, number 3. It says use the equation of the tangent line to approximate the value of y when x is equal to negative 3.9. Then find the value of f of negative 3.9. So I'm going to use the equation of my tangent line right here, and I'm just going to substitute in negative 3.9 for x. So I get y plus 2 is equal to negative 2 times the quantity negative 3.9 plus 4. At this point, you could jump to your calculator. You can just write out the steps. I'm going to get y plus 2 is equal to negative 2 times 0.1, which is going to give me y plus 2 is equal to negative 0.2. Make sure I have those equal signs, or equal sign. And then I'm going to subtract 2 from both sides. So I'm going to get y is equal to negative 2.2. So that's the estimate using my tangent line. Now they want me to find the actual value using my function. So f of negative 3.9. And you can just pause the video, punch this into your calculator to figure this out. I'm not going to work through all the algebra, nor would they expect you to here on an AP exam. And our actual value of f of negative 3.9 is negative 2.195. So you can see that our approximate value was very, very close to our actual value. And this is going to tie into what question 4 is asking us. Let me erase this and we'll go look at question 4. So question 4 says, what do you notice about both results from number 3? What does this imply about how the equation of the tangent line may be used? So we'll just write the answer to this up here. But essentially the approximation using the tangent line was close to the actual value of the function. So essentially this means that we can use the tangent line to estimate values of the function that are very close to the point of tangency, right? Let me zoom in on this graph real quick and kind of show you what I mean. Okay, so if I draw the tangent line to my graph at x equals negative 4, where it looks something like this. If you pick a point that's far away from the point of tangency, so let's say I pick this point right here. Okay, notice that this value on the tangent line is not very close to the actual value here, right? The value on the tangent line is about 1.5, whereas the actual value of the function is closer to 4. So using the tangent line here for x equals negative 5 would be, or sorry, this is x equals negative 6, would be a very poor estimate. But if I choose a point that's very, very close to the point of tangency, right? If I choose a point that's right here in green, right? That point is basically on the original function, right? It's very, very close to the value of the original function. And it gets even better as you get closer and closer to the point of tangency from either side. So if you choose an x value that's very close to the point of tangency, the tangent line is going to be a pretty good estimate of the actual value of the function at that point. But the further away you get, right? When we were up here, the difference between the y value for the tangent line and the y value for the function, that gap got larger and larger as you got farther and farther away from this point of tangency. But if we choose an x value that's very, very close, we can get a pretty good estimate for the value of the function at that point. Okay, I am going to zoom back out for us, and we'll write down our thoughts to number 5. Or that was rather number 4. So we can say the tangent line, again, this is just an answer to number 4, can be used to estimate values of the function when the x value is close to the point of tangency. Again, this was our answer to number 4. All right, let's move on and see if we can get one more question done for this part of the video. All right, so on this page, we're given a graph of the function g of x. So I'm going to start by labeling as such. And the first question asks us, based on the graph, at what value or values does a graph have a horizontal tangent? Give a reason and show algebraic analysis that supports your answer. So we just need to figure out where it looks like we could draw a horizontal tangent line. And it looks like the only spot is right at x equals 1. Certainly looks like there is a horizontal tangent there. Now, while it looks like there's a horizontal tangent there, we'd like to be sure using some algebraic analysis. So we're going to use the algebraic form of the function to see if the derivative is equal to 0 at that point, right? Because if we have a horizontal tangent, that means the slope of the tangent line is 0, which means the derivative should be equal to 0. So we actually have to take the derivative of g of x and see if we have a 0 when x is equal to 1. So let's go ahead and do that. First thing I'm going to do is I'm going to rewrite g of x so that we can better use the power rule. So it's going to be 2 times x to the 1/2 power minus x plus 2. Now it's pretty easy to apply the power rule. G prime of x is going to be equal to x to the negative 1/2 power minus 1. Now, it's probably easier for you to work with the derivative if it's back in radical form. So that's what we're going to do. So g prime of x is equal to 1 over the square root of x. If you're not sure about that algebraic manipulation, you may want to pause the video and think through that, how we change negative exponents to positive exponents, then go from exponents to radicals. So I'm actually going to see if there's more than one 0. So it looks like the graph only has one horizontal tangent. I'm going to see if there's any other values for x where that's true. So I'm going to set the derivative equal to 0 and see what values of x we come up with. So add 1 to both sides, multiply both sides by the square root of x, and square both sides so I get x is equal to 1. So we do have a horizontal tangent at 1 because the derivative at x equals 1 is equal to 0. So that would be your algebraic analysis that you would need to show for this problem. So horizontal tangent at x equals 1 because g prime of 1 is equal to 0. Okay, let's look at 6. So 6 and 7 are related. One of them asks, where is g prime less than 0, or where is it negative? And 7 asks, on what intervals is g prime positive or greater than 0? So if you think back to our last lesson, we came up with this number line for the derivative. And this was to help us understand, so this is going to represent g prime of x. And this was to help us break the derivative up into positive and negative intervals. Now, we actually have to be careful here because g prime of x does not go from negative infinity to infinity, right? This is not the domain because the domain of g of x up here, right, is just 0 to infinity. The function up here is never, we can't substitute in any negative x values, which means we also can't substitute in any negative x values in our derivative. So I'm going to actually get rid of this. And the derivative is going to be all real numbers greater than 0. We'll get into this a little bit more later, but if we substituted in 0 in our derivative, that would make our derivative undefined. We'll talk about why that is in a later lesson, but the domain of this derivative, g prime, is all the real numbers greater than 0, or all the positive real numbers. So we know we can split this domain up into two parts, an interval from 0 to 1 and an interval from 1 to infinity, because 1 is the only 0. So every other point in the domain, or every other x value, is going to give us, like if we look at, let me try to rephrase that. So if I look at this interval 0 to 1, all of the y values for g prime are either going to be all positive or all negative. Same thing for this interval right here. So we have to test a point. We need to test 2 points actually. One for in between 0 to 1. So I'll test g prime of 0.5, and I'll test a point, we'll say g prime of 2, because 2 is between 1 and infinity. So you can just pause the video here, type those values into your calculator, and see what you get for those two g. So for g prime of 0.5, we end up getting approximately 0.414. What that means is that all the g prime values from 0 to 1 are going to be positive, and g prime of 2 was equal to a negative number, negative 0.293 approximately. So all the values from 1 to infinity of g prime are going to be negative. So this very clearly tells us on what intervals g prime is negative versus where g prime is positive. This should also tell us something about g of x, right? If the derivative is positive, so if we're looking at number 7, if g prime is greater than 0, then g of x is going to be increasing. Whereas if g prime is less than 0, g of x will be decreasing. So our two intervals here, we have g prime being less than 0 from 1 to infinity, and g prime is greater than 0 from 0 to 1. Your work right here would show the AP reader or whoever is grading your test that you understand a justification for how to figure, or not justification, but you would understand how to figure out where g prime was less than or greater than 0. Again, I think I would also write down what this means about g of x. So g of x is decreasing on this interval. And that shows you know the relationship between g of x and g prime. Down here, g of x is increasing on this interval. Okay, I'm going to erase what we have. We do have 2 more questions regarding this graph, but I want to give us some more space. So question 8 says, for what values of x is the slope of the tangent line equal to 2? So I'm going to come back up here. I'm going to write down what our derivative was. So we had g prime was equal to 1 divided by the square root of x minus 1. And it says at what x values is the slope of the tangent line equal to 2? Well, the slope of the tangent line is the value of the derivative. So we just need to figure out where g prime is equal to 2. So we substitute in 2 for g prime and solve for x. So I add 1 to both sides, multiply both sides by the square root of x, divide both sides by 3, and square both sides. After I square, I'll just be left with x. So I get x is equal to 1/9. So when x is equal to 1/9, the slope of the tangent line is equal to 2. So this work, again, for number 8. Again, that relationship is the slope of the tangent line is another way of just describing a derivative. All right, final question on this page, and then we are going to be done with part 1 for this video. Number 9 says, find an equation of the tangent line drawn to the graph of g of x when x is equal to 4. Then draw the tangent line on the grid above. So we need the equation of a tangent line when x is equal to 4. So let's do our work right here. This is going to be number 9. We're always going to start out with point-slope form when we're building the equation of a line. So y minus y1 equals m times the quantity x minus x1. Now we know that x is equal to 4, so we have our x1. To find our y1, well, we're given our original function, and if we know the x value, we should just substitute in to find the y value. So g of 4 is equal to 2 times the square root of 4 minus 4 plus 2. That means g of 4 is equal to 2. So I've got y minus 2 is equal to some slope times the quantity x minus 4. Now we need the m is the slope of the tangent line, which again is the value of the derivative. So we have our derivative, right? We know that our derivative is g prime of x is equal to 1 divided by the square root of x minus 1. We need to find the slope of the tangent line at x equals 4. So we just need to find g prime of 4. So this gives us 1/2 minus 1, which is equal to -1/2. So there you have it. That is the slope of the tangent line. Okay, we will come back with a part 2 and work through some of the other questions in this packet. Until then, as always, this has been Mr. Fawcett, and enjoy the rest of your day.